Welcome to my channel SP Star Chemistry. Today I am going to discuss you about the Birch reduction. Birch reduction is nothing but the reduction of the aromatic ring to a 1,4-cyclohexadiene in the presence of sodium or lithium as metal and in liquid ammonia and ethanol as a solvent. Firstly, what happens in this reaction? The lithium donates an electron and it forms the lithium positive plus electron. Now, due to this electron, the solution becomes blue in color, and in the next step, this electron again reduces the ammonia and it forms the NH2 minus and half of the H2. Now, due to this NH2 minus, the solution become colorless and it indicates the reduction of the ammonia to NH2 minus. We will discuss about the mechanism of the Birch reduction. Here the electron withdrawing group is present, and we know that in the Birch reduction, whenever the electron withdrawing group is present, it stabilizes the electron density at the ipso and para position. And firstly, this NH2 minus is basic in nature and it abstracts the proton from here and we get this. This proton is acidic in nature due to the heteroatom, that is the oxygen. In the next step, the sodium or the lithium donates electron, then this bond shifts here, then again this bond shifts here and oxygen becomes negatively charged. And we get this. This system is again in a equilibrium with this. So, firstly, the protonation takes place at the para position. Again, in the next step, sodium or the lithium donates an electron and we get this. And again, the proton source stabilizes this negative charge and we get the 1,4-cyclohexadiene, and whenever the electron donating group is present in the Birch reduction, the electron density stabilizes at the ortho and meta position. Therefore, what happens? This sodium donates an electron at the meta position, and then this bond shifts here and we will get the negative charge here. Now this negative charge takes proton from the proton source and we get this. In the next step, again the sodium donates electron and we get this. Here negative charge. Then it abstracts proton and we get this system. The trick to remember the Birch reduction in case of the electron donating group is that the sp2 carbon remains sp2, means wherever that electron donating group is present, that carbon always remain sp2 in nature. In this example also, the Birch reduction happens and this carbon where this electron donating group is present, it always remain sp2 in nature, and to this carbon also the electron donating group is present, therefore it is also remain sp2 and we get this product. Now in this example, we know that the Birch reduction condition is an electron rich condition. Therefore, what happens? It always reduces the electron deficient ring, and out of these two benzene ring, this is the electron deficient and this is a electron rich due to this methyl group, and the Birch reduction reduces this electron deficient ring and we get the product where this carbon is remain sp2. Now in this example, the electron donating as well as electron withdrawing group is present. So whenever there is a possibility of the presence of the electron donating as well as the electron withdrawing group, the Birch reduction goes in accordance with this electron withdrawing group and we get the product where these carbons remain sp3 in nature, and we know that the trick for the Birch reduction when the electron withdrawing group is present is that the carbon where the electron withdrawing group is present, it becomes sp3 after the Birch reduction. Now in this example also, here this ring is the electron rich due to this methyl group, and this is the electron deficient due to this electron withdrawing COOH group. So the Birch reduction is electron rich system. So it reduces this electron deficient ring and we get the product where this carbon again remain sp3 in nature. Now in this example, firstly the NH2 minus removes this most acidic proton and we get this. And in the next step, this sodium donates an electron. Then this bond shifts here and again the oxygen becomes negatively charged. And we get this now in the next step again this is in equilibrium with this system. Now what happens? This takes a proton and we get this system, and again the sodium donates an electron to form here negative charge. Now methyl iodide is given. This negative charge attacks on this carbon and removal of the iodine takes place. And we get here the methyl group, that is the alkylation takes place. And again the NH4Cl is given, which is workup condition. And finally we get this product. In all this example, the OMe group remain. Now in this example, the ester group is present and it is electron withdrawing in nature, and in the Birch reduction, whenever the electron withdrawing groups like the aldehyde, ketone and ester is present, the Birch reduction condition reduces that to a CH2OH group, that is the electron donating group, and then the Birch reduction goes in accordance with that electron donating group. But what happens when we take this condition, water 1.5 equivalents THF and ammonia, this ester moiety is remains, and we get the product where the Birch reduction goes in accordance with this electron withdrawing group. Now, in this example, the Birch reduction condition reduces this ring and we get this product. Again, the weak acid is given, that is the oxalic acid, and whenever the weak acid is given, we get the beta gamma unsaturated compound. And here this enol ether is converted into the beta gamma unsaturated system. And whenever the strong acid is given, firstly what happens, this enol get hydrolyzed, and we get this beta gamma unsaturated system. But again in the acidic condition, the protonation takes place and we get the enol. Now this enol takes proton through a long conjugation and we get alpha beta unsaturated system. That is, whenever the strong acid is given, we get the alpha beta unsaturated system, and whenever the weak acid is given, we get the beta gamma unsaturated system. If you find the content is good, please do like, share and subscribe to my channel. Thank you for watching video.